Yes, come to the live session, all of you. Molecular orbital theory. Now we are going to discuss molecular orbital theory. Hello, my dear students. Come to the live session. We'll discuss molecular orbital theory now. So both concept and as usual concepts and previous year questions also we'll discuss. Come to the live session. So molecular orbital theory we have to discuss about. Molecular orbital theory. Simply we are calling it as MOT, molecular orbital theory. Actually, why we have discussed about the molecular theory? Sir, ఎందుకోసం molecular orbital theory discuss చేయాల్సి వచ్చింది, introduce చేయాల్సి వచ్చింది అంటే సో బికాస్ ఆఫ్ O2 molecule. సో O2 molecule గురించి దీన్ని డిస్కస్ చేయాల్సి వచ్చింది. సో why? Because sir, according to VBT, valency bond theory in case if it is, valency bond in case if it is, sir, here oxygen, the two bonds it will be formed in between them. One is sigma bond formation. Sigma bond formation జరిగినప్పుడు sir px orbitals both overlapping, head on head overlapping, sigma bond formation takes place. Then pi bond overlapping, partial overlapping, pi bond formation takes place. So in between oxygen and oxygen, double bond is formed. One is sigma bond, one more pi bond. Sir, generally according to when we are discussing about the magnetism, wherever the lone pair of or unpaired electron is present, then paramagnetic behavior, paired electrons are there, diamagnetic behavior we can explain. Once the bond formation takes place, here two electrons are paired, even the partial overlapping also two electrons are paired. There is no unpaired electrons according to VBT. That means it is a diamagnetic in nature. So according to valency bond theory, so O2 molecule diamagnetic in nature, but experimentally O2 molecule is paramagnetic in nature. So you have to remember, sir, experimentally O2 molecule is paramagnetic behavior. సో దీన్ని ఎక్స్ప్లెయిన్ చేయడం కోసం, పారామాగ్నెటిక్ అని ఎక్స్ప్లెయిన్ చేయడం కోసం సార్ మాలిక్యులర్ ఆర్బిటల్ థియరీస్ ఇంట్రడ్యూస్డ్. సో దట్స్ వాట్ ఈస్ ద మాలిక్యులర్ ఆర్బిటల్ థియరీ దాట్ వీ హ్యావ్ టు డిస్కస్. సార్ ఏంటి మాలిక్యులర్ ఆర్బిటల్ థియరీ అనేది ఇప్పుడు మనం డిస్కస్ చేద్దాం. సో అకార్డింగ్ టు మాలిక్యులర్ ఆర్బిటల్ థియరీ, ఆక్సిజన్ మాలిక్యూల్ పారామాగ్నెటిక్ అని ఎలా ఎక్స్ప్లెయిన్ చేశారనేది కూడా మనం ఇందులో డిస్కస్ చేయొచ్చు. సార్ ఈవెన్ ప్రీవియస్ ఇయర్ క్వశ్చన్స్ మాలిక్యులర్ ఆర్బిటల్ థియరీని బేస్ చేసుకొని ప్రీవియస్ ఇయర్ క్వశ్చన్స్ ఏమేమి అడిగారు, సో దాన్ని కూడా మనం డిస్కస్ చేద్దాం. దెన్ ఫస్ట్ ఆఫ్ ఆల్ మెయిన్ పాయింట్స్, వాట్ ఆర్ ద మెయిన్ పాయింట్స్ ఆర్ దేర్ ఇన్ దిస్ that we have to discuss. Sir, in that first one, so generally atomic orbitals present in atoms లో atomic orbitals ఉంటాయి, but molecular orbitals present in molecules లో molecular orbitals ఉంటాయి, atoms లో atomic orbitals ఉంటాయి. That we have to remember. Then next one, atomic orbitals ని జనరల్ గా మనం ఎలా రిప్రజెంట్ చేస్తాం? Atomic orbitals are representing like this. Sir, how 1s, then 2s, 2p, then 3s, like this we are representing. But molecular orbitals are representing like this in the molecular orbital theory. How it is? Sigma 1s, sigma star 1s, then pi px equals to pi py, like this we are representing. So sigma 1s, sigma star 1s, pi p equals to pi px equals to py, like this we are representing. So then third one you have to remember. So that are, so number of molecular orbitals, number of molecular orbitals are formed equals to number of atomic orbitals are combined, number of atomic orbitals combined. This is very important, remember. So 3 points ఒకసారి చూడండి. So atomic orbitals are present in the atoms, molecular orbitals are present in the molecules. Atomic orbitals are representing 1s, 2s, 2p, 3s, 3p, 3d, like this. But molecular orbitals are representing sigma 1s, sigma star 1s, then sigma 2s, sigma star 2s, then pi 2px equals to pi 2py, like this we are representing. The number of molecular orbitals are formed is equals to number of then atomic orbitals are combined. How many they are combined, that we have to discuss like that. Clear, my dear students? Then one more point we'll discuss on it. So these 3 points are very important points. The next, how the molecular orbitals are formed by the combining of atomic orbitals. For example, that is 4th point, look at. For example, here, then 1s atomic orbital is there. 1s atomic orbital, then 1s atomic orbital, both will be combined. Then atomic orbital, then orbital wave function, we have to take it as psi1, then even this is also taken as psi2. Once both are combined to form, so how many are combining? The same number of molecular orbitals will be formed, I told. So ఎన్నైతే కంబైన్ అవుతున్నాయో అన్ని molecular orbitals form అవుతాయి. So molecular orbitals will be formed like this, molecular orbitals. Clear? So these are, we are telling atomic orbitals. So these are molecular orbitals. See, molecular orbitals lo, 2 molecular orbitals lo, which are below one is there. So that is bonding molecular orbital. Then above one, anti-bonding molecular orbital. Bonding molecular orbital, anti-bonding molecular orbital. Bonding, anti-bonding. Bonding, anti-bonding, like this. So here, how the bonding molecular orbital will be formed? So actually psi nothing but it is a wave function of orbital, right? So wave function we have to take like this. So this is psi1. The wave function of one atomic orbital plus the wave function of another atomic orbital, if you take, then you can get the bonding molecular orbital. That wave function, it will be strengthened like this, strengthen. So these are the atomic orbitals wave functions, psi1, then psi2, then atomic orbital wave functions. So this is molecular orbital wave function. Clear? Then in case, so when subtraction takes place, the wave functions of both atomic orbitals, subtractions are taking place, then psi 1, then psi 2, atomic orbitals of both, atomic orbitals of both. Then you can get here, so normal line like this. The both lobes are cancelled with each other when subtraction takes place, not addition, subtraction. Sir, wherever the addition takes place, that we call constructive interference. Constructive interference. Constructive interference. Wherever subtraction is takes place, that is destructive interference. Destructive interference. Interference. Then anti-bonding molecular orbitals. Anti-bonding molecular orbitals. Remember, wherever the bonding molecular orbitals will be formed, so these are bonding molecular orbitals. Bonding molecular orbitals will be formed by the constructive interference, nothing but by the addition of both waves. Then destructive interference will be formed by the subtraction of both waves. Sir, wherever the bonding molecular orbitals are there, that is having the less energy, but more stable. Less energy, more stable. Sir, here, so these are more energy, less stable. Remember both. So which are bonding molecular orbitals are more stable, less energy. But anti-bonding molecular orbitals are less stable, but more energy. Clear, all of you? Understand? So constructive interference and destructive interference, how does it takes place? Then what formation taking place, that we have to discuss. So note the next one. Now, fifth point, if you take. Fifth point, that is. So what were the atomic orbitals are combining? That must be same energy, then same shape, or nearly same energy. Combining atomic orbitals must have same energy or nearly same energy. That is fifth one. Combining atomic orbitals have same energy or nearly same energy. Nearly same energy. Then same shape also. Same shape. Nothing but look at. So s orbital both will be combined. Then otherwise px orbital, then px orbital both will be combined. Then py orbital, both will be combined. So same shape, then nearly same energy containing orbitals only, that will be combined and produces molecular orbitals. Clear? Yes. So next, sixth one, electronic configuration of molecules follows following rules. Sir, atomic orbitals ni follow cheyadaniki elanti rules aithe manam use chestamu. So Aufbau rule, then Pauli's rule, then Hund's rule. Sir, Aufbau's rule, then second one Pauli's rule, then third one Hund's rule. So these rules, even molecular orbital electronic configuration also that follows the same rules. Sir, what is the off-bow rule? Once just recall it. Off-bow rule. So off-bow rule ఏం చెప్తా ఉంది? So first lower energy orbitals will be filled by the electrons, then followed by higher energy orbitals. So lower energy orbitals ఏమొస్తాయి? First bonding molecular orbitals, then after anti-bonding molecular orbitals. So first bonding molecular orbitals, then followed by anti-bonding molecular orbitals. Clear? Then Pauli's rule ఏం చెప్తా ఉంది? So what it will tell the Pauli's rule? So ఒక ఆర్బిటాల్ లో ఎలక్ట్రాన్స్ ఫిల్ అయినప్పుడు then both electrons must be with different spins. రెండు కూడా different spins లో ఉండాలి. So Hund's rule ఏం చెప్తా ఉంది? In case equal energy containing orbitals are there, first fill one electron in each orbital, then followed by second electron. Equal energy containing orbitals ఉన్నప్పుడు ఒక్కొక్క ఎలక్ట్రాన్ ని ఒక్కొక్క ఆర్బిటాల్ లో ఫిల్ చేయాలి. Then after you have to pair up. సరే, ఏ రూల్ ని ఫాలో అవ్వట్లేదు మాలిక్యులర్ ఆర్బిటల్ థియరీ, ఏ రూల్ ని ఫాలో అవ్వట్లేదు అంటే n+l రూల్, that is energy rules, sir, which is having a higher energy, which is having the lower energy, does not follow this rule. ఈ రూల్ ఫాలో అవ్వట్లేదు. Clear all of you? Then so last one, the order of molecular orbitals while writing the electronic configuration. రాయడానికి so order of molecular orbitals that we have to note. Yes, if less than 18 electrons are there, if less than 14 electrons, less than equals to 14 electrons are present in the molecule, then electronic configuration, how to fill it? So look at the electronic configuration order, you have to note it. Sigma 1s, then sigma star 1s, sigma 2s, sigma star 2s, then pi 2px equals to pi 2py, then sigma 2pz, then next pi star 2px, equals to pi star 2py, then sigma star 2pz. This is for 14 electrons or less than 14 electrons. 14 electrons, less than 14 electrons. Sir, in case more than 14 electrons, if more than 14 electrons are present, then what is the electronic configuration? Up to here the same. Sir, here the sigma 2pz, it will come to here. So more than electronic configuration is there. So how to write the electronic configuration? Look at once. The sigma 1s, sigma star 1s, then sigma 2s, then sigma star 2s, then pi, what you have to take? Then sigma 2pz have to take, then pi 2px equals to pi 2py, then pi star 2px equals to pi star 2py, then after sigma star 2pz. Clear, understand, my dear students? So this is the electronic configuration for less than 14 electrons and greater than 14 electrons, how to write. Okay, So look at all of you. So next, how to find out the electronic configuration for each molecule. Then first, so some of the molecules we'll discuss. So how to write the electronic configuration and bond order, how to find out. Then bond length, how to find out. And the previous year questions, how to find out. So look at all of you. Look at. So some very few molecules we'll discuss. So for example, in case you take first molecule, H2 molecule. So this is the molecule. Number of electrons, how many should be present in it? So one hydrogen, one electron. The two hydrogens, two electron. Then how to write the electronic configuration? Sigma 1s2, like this. Sigma 1s2. Clear? Understand? So second one, then in case helium 2, if you take, then helium, each helium 2 electrons, 2 heliums 4 electrons. Then sigma 1s2, sigma star 1s2. 4 electrons are done. Then in case lithium 2, lithium 2. Then how many electrons? 3 plus 3, 6 electrons are present. Then sigma 1s2, sigma star 1s2, then sigma 2s2, like this you have to take. Then, so next fourth one, if you take, so hydrogen, helium, lithium, beryllium, Be2. Then electronic configuration, so sigma 1s2, so sigma star 1s2, then sigma 2s2, then sigma star 2s2. You have to take like this. Then fifth one, look at beryllium after boron, B2. Sir, how many electrons? 10 electrons. So each boron 5, 2 borons, 10 electrons. Sigma 1s2, sigma star 1s2, sigma star 1s2, then sigma 2s2, then sigma star 2s2, then, so look at here, observe it carefully, B2. So then after what you can get for the less than 14 electrons, pi 2px equals to pi 2py. Equal energy unnadi electrons lo. Equal energy unnappudu, sir, one electron you have to fill in each, because then 10 electrons here, up to here 8 electrons are done. Then the remaining 10 electrons, in case if you fill 2 electrons at a time here, that is wrong. Sir, one electron you have to fill in each, because equal energy containing orbitals you have to fill 1 electron in each according to Hund's rule, right? Yes. The next sixth one, look at carbon C2. Then electronic configuration, atomic number for the carbon is 6, then 12 electrons, right? So note it, sigma 1s2, then sigma star 1s2, then sigma 2s2, then sigma star 2s2, then pi 2px equals to pi 2py. So first one electron, if it is filled, then remaining 2 electrons will be present. So you have to fill it is 2 electrons in each. Then total, so 8 here, 9, 10, 11, 12. Yes, 12 electrons are done. So you have to note down the electronic configuration like this. Later, we can find out the bond order of each molecule also. Bond order ela find out chestam sir. Bonding electrons minus anti-bonding electrons divided by 2 have to take. For example, if you take bond order for this molecule, which is H2 molecule. So bond order, how to find out? Bonding electrons, how many are there? 2 are there. Anti-bonding electrons, nothing will be there, 0. Then divided by 2. Nothing but 2 by 2, it is equals to 1. Bond order 1, nothing but. In between the 2 atoms, only 1 bond will be present. That means hydrogen bond hydrogen is present like this. Clear, my dear students? Then come to the helium. Then bond order, how to find out? Bond order equals to. Then bonding electrons are 2 minus anti-bonding electrons are 2 divided by 2. 2 minus 2, 0. 0 divided by 2 equals to 0. Where bond order is exist, very, very important, man. which of the following will not exist? Like such type of question if they will ask. Bond order ఏ మాలిక్యూల్ కి జీరో అవుతుందో ఆ మాలిక్యూల్స్ do not exist. So molecules exist అవ్వవు nature లో. Then lithium 2, in case if you take bond order, how to find out? Look at bond order equals to, then bonding electrons. So here 2, then here 2, total 4 minus 2 divided by 2. Then 2 divided by 2, bond order you can get 1. Clear? Then Be2, look at the bond order, how to find out? Sir, bonding electrons here 2, then here 2, so total 4 again. These are 4 minus 4 divided by 2, then 0 divided by 2, you can get 0. So wherever the bond order you can get 0, that molecule do not exist. Remember, it is also very, very important. So Be2 molecule, He2 molecule do not exist. Then B2 molecules, look at. So bond order, how to find out? The bond order equals to, bonding electrons are how many are there? 2 plus 2, 4 plus 2, 6 minus, how many are there? Antibonding 4 are there. 6 minus 4 divided by 2, 6 minus 4, how much, man? 2 divided by 2, then you can get 1. So bond order is 1. Then if you come to the 12 electrons, that is C2 molecule, so find out the bond order. So bond order equals to, then bonding electrons 2 plus 2 plus, then here 4, so total 8. So 8 minus antibonding electrons are 4, so 4 divided by 2, nothing but 4 by 2, then you can get 2. So bond order you can get 2 for the C2 molecule. Both are pi bonds only, that you have to observe. Sir, C2 molecule lo rendu kuda according to molecular orbital theory pi bonds. They will ask a question, in which of the following molecule only pi bonds are present? C2 molecule. Clear? Understand? So bond order find out cheyachu, electronic configuration rayachu. Bond order find out chesin tarvata, then bond order 0 vaste molecule does not exist. Bond order 0 vaste beryllium kuda 0 ochindi, does not exist. Clear? That is, sir, once N2 molecule if you take, so actually molecular orbital theory we are discussing for what? Molecular orbital theory we are discussing for what? Molecular orbital theory is discussing for oxygen molecule is, to prove the oxygen molecule is paramagnetic. Oxygen molecule paramagnetic and explain cheyadam kosam తీసుకున్నాం. So N2 molecule, in case if you take N2, so 7 plus 7, 14 electrons, less than 14 and 14 electrons, electronic configuration we know, sigma 1s2, then sigma star 1s2, then sigma 2s2, then sigma star 2s2, then pi 2px equals to, then pi 2py, then 2t electrons in each. So total, how many are done? 12 electrons are done, right? Then after sigma 2pz, sigma 2pz2. So up to here 14 electrons are done. Look at 1, 2, 3, 4, 5, 6, 7, 7 to 14. So bond order, how to find out, man? Bond order equals to number of bonding electrons, 2 plus 2, 4 plus 4, 8, 8 plus 2, 10. 10 minus antibonding, antibonding only 4, minus 4 divided by 2, then you can get 6 divided by 2, then 3. So bond order 3, nothing but in between the two atoms bonds are 3 bonds are present. Clear, all of you? Understand my dear students? Yes, look at the next O2 molecule if you take. So how many electrons are there in the O2 molecule? 16 electrons are there. So look at the electronic configuration. So more than 14 electrons unnappudu sigma 1s2, sigma star 1s2, sigma 2s2, then sigma star 2s2, ikkada varaku same ga untundi. Then if you come to there, this orbital will come to here. That is what? Sigma 2pz2. Then pi 2px equals to pi 2py. Then two electrons clear. Yes. Then two more electrons we have to fill it. Then pi star 2px equals to pi star 2py. Then look at. So here one electron you have to fill because both are equal, right? So up to here 16 electrons are done. Electronic configuration rastunnappudu, wherever single electron is filled, observe it carefully. Wherever single electron is filled, that is belongs to the paramagnetic behavior. So this is paramagnetic in nature. Paramagnetic in nature. Then bond order, if you find out, bond order equals to number of bonding electrons are how many are there? Look at. So 2 plus 2, 4. 4 plus 2, 6. 6 plus 4, 10. 10 minus anti-bonding, look at 4 plus 2, 6, then divided by 2, then 4 divided by 2, then you can get 2. Bond order is 2, nothing but what I told. In between the two atoms, two bonds are present. Clear? So more than this, sir, whatever the electronic configuration is there, you have to take the electronic configuration, then follows according to the electronic configuration like this. Clear? Understand all of you, my dear students? Right. So now one of the shortcut method I will tell to you how to find out the bond order in case without electronic configuration. Electronic configuration lekunda bond order ni ela find out cheyochu. Shortcut trick I will tell to you people. Ela find out cheyochu. So first, if you take, in case 14 electrons are there, number of electrons, 14 electrons are there, bond order is 3. We have seen now the N molecule, N2 molecule bond order find out chesinapudu enta vachindi manaku 3. Then in case 15 electrons are there, so 0.5 have to less it, that is 2.5 fractional bond order. Then 16 electrons are there, then take it as 2. 17 electrons are there, 1.5. 18 electrons are there, 1. 19 electrons are there, 0.5. 20 electrons are there, 0. Bond order is 0. Next, 13 electrons are there, 2.5. 12 electrons are there, 2. 11 electrons are there, 1.5. 10 electrons are there, 1. 9 electrons are there, 0.5. 8 electrons are there, we have seen beryllium. 8 electrons, bond order is 0. Wherever the 0 bond order is there, molecule does not exist. So based on the bond order, you have to tell. అంటే ప్రతిసారి ఎలక్ట్రానిక్ కాన్ఫిగరేషన్ రాసుకోవాల్సిన అవసరం లేదు. సో ఈ ట్రిక్ మీకు తెలిసింటే, సో ఫస్ట్ ఎలా తీసుకోవాలి, 14 ఎలక్ట్రాన్స్ తీసుకోవాలి, 14 ఎలక్ట్రాన్స్ 3 తీసుకోవాలి. 14 కంటే ఎక్కువ ఒక్కొక్క ఎలక్ట్రాన్ ఫిల్ చేస్తూ ఉన్నప్పుడు, ఒక్కొక్క ఎలక్ట్రాన్ యాడ్ చేస్తున్నప్పుడు 0.5 0.5 0.5 0.5 డిక్రీజ్ చేస్తూ రావాలి అప్ టు 20 ఎలక్ట్రాన్స్. అలాగే పైకి వెళ్ళినా కూడా 13 ఎలక్ట్రాన్స్, 12 ఎలక్ట్రాన్స్, 11 ఎలక్ట్రాన్స్ 0.5 0.5 0.5 డిక్రీజ్ చేస్తూ రావాలి. Clear, my dear students? Right. So look at some of the questions from MCET. MCET లో అడిగిన కొన్ని క్వశ్చన్స్ మనం డిస్కస్ చేస్తే, the sum of bond order of O2 plus O2 minus O2 and O2 plus 2 is equals to is equals to, this is the question. ఈ క్వశ్చన్ 2025 మే థర్డ్ ఈ క్వశ్చన్ ఎంసెట్ లో వచ్చిన క్వశ్చన్. ఇది షిఫ్ట్ 1 లో వచ్చిన క్వశ్చన్. అబ్జర్వ్ ద క్వశ్చన్ కేర్ఫుల్లీ. ఆప్షన్స్ ఇచ్చారు 5, 4, 6, 9 like this is given. B, C, D. So based on MOT, molecular orbital theory, bond order ని బేస్ చేసుకొని అడిగిన క్వశ్చన్ ఇది. సో ఇక్కడ నేను ఏం చెప్పాను? సో O2 ప్లస్, O2 మైనస్, O2, దెన్ O2 ప్లస్ 2. O2 ప్లస్, యాక్చువల్గా O2 అంటే ఎన్ని ఎలక్ట్రాన్స్ మా? 16 ఎలక్ట్రాన్స్. O2 మైనస్ అంటే ఒక ఎలక్ట్రాన్ యాడ్ చేయాలి, 17 ఎలక్ట్రాన్స్. O2 ప్లస్ అంటే 16 లో ఒకటి తీసేయాలి, అంటే 15 ఎలక్ట్రాన్స్. దెన్ O2 ప్లస్ 2 అంటే 14 ఎలక్ట్రాన్స్. 14 ఎలక్ట్రాన్స్ ఉన్నప్పుడు బాండ్ ఆర్డర్ ఎంత? 3. దెన్ 16 ఎలక్ట్రాన్స్ ఉన్నప్పుడు బాండ్ ఆర్డర్ ఎంత? 2. 17 ఎలక్ట్రాన్స్ ఉన్నప్పుడు బాండ్ ఆర్డర్ ఎంత? 1.5. 15 ఎలక్ట్రాన్స్ ఉన్నప్పుడు బాండ్ ఆర్డర్ ఎంత? 2.5. ఎస్. సో 2.5 ప్లస్ 1.5 హౌ మచ్? 4. 4 plus 2, 7. Sorry, 4 plus 2, 6. 6 plus 3, 9. So total bond order is 9. So answer is 9. Clear, my dear students? Then one more question, look at. One more question. So same based on bond order only. Or otherwise, which of the following molecule can be exist or not exist? Such type of questions they're asking in the examination. Identify the pair in which difference in the bond order value is maximum. Second question, identify the pair in which difference in bond order value is maximum. Difference in bond order value is maximum. Sir, options are given. Look at difference in the bond order. O2 minus, O2 plus. Then B, O2, O2 plus 2. Then C, O2 minus 2. Then O2 plus 2. Then D, O2 plus, O2 plus 2. Look at what will be there in this. So O2 is there. Then O2 plus is there. O2 plus 2 is there. O2 minus is there. O2 minus 2 is there. O2 minus is there. O2 minus 2 is there. O2 16 electrons, then 17 electrons, then 18 electrons, then 15, then 14 electrons. So 16 electrons bond order is 2. Then 15 electrons bond order is 2.5. Then 14 electrons bond order is 3. Then O2 minus 2 bond order, 18 electrons bond order is what? 1. Then 17 electrons bond order is 1.5. Where the difference, much difference will be there. Sir, O2 minus, O2 plus, O2 minus, O2 plus. Then O2 minus 2, O2 plus 2. Look at. So here the bond order. So 2 will be there. Difference in the bond order is 2. So that you can identify like this. Understand? So look at one more question. Look at one more question. Right, it's a very important question. According to MOT, question number 3, according to MOT, the molecule which contains, the molecule which contains only pi bonds, between atoms. ఈ క్వశ్చన్ 2023 మే 14th అడిగిన క్వశ్చన్. మే 14th షిఫ్ట్ 2 షిఫ్ట్ 1 లో అడిగిన క్వశ్చన్. ఇట్స్ వెరీ ఇంపార్టెంట్ క్వశ్చన్. సో లుక్ ఎట్ ఆప్షన్ 7, C2, N2, O2, B2. C2, N2, O2, B2, like this. Yes, look my dear students. So this is also one of the most important question. So what is there? Only pi bonds I told. The C2 molecule, now only we have discussed the C2 molecule bond order is 2. The C2 molecule bond order is 2, then bond order, and between the two pi bonds it will be formed. So that's what the two bonds in between the carbon double bond is there. So both pi bonds only is present in the C2 molecule according to MOT. Exceptional case it is MOT. It is very, very important. Okay, clear? Yes. So ఇందాక మనం డిస్కస్ చేసినప్పుడు కూడా ఈ విషయాన్ని మనం మెన్షన్ చేశాం, రైట్? The next most important question, that is question number 4. Question number 4. Arrange the molecules. Question number 4. Arrange the molecules. So B2, He2, N2 and C2 in the increasing order of their bond order values. In the increasing order of their bond order values. So this is the question actually. This question is given 2023 May 14th only. 2023 May 14th లో అడిగిన క్వశ్చనే. May 14th. So that is also shift, not shift 1, shift 2 it is. Clear? Yes, look my dear students. The bond order for the B2 how much? B2, then He2, then N2, then C2. So C2 number of electrons are 12 electrons. N2 14 electrons. ఎలా తీసుకోవాలి ఇట్ని? కార్బన్, ఈచ్ కార్బన్ 6, then 6 plus 6 12, 7 nitrogen, 7 plus 7 14, helium 2 plus 2 4, then B2, boron 5 plus 5 10 number of electrons. Clear? Understand? Yes. Look, 14 electrons bond order is 3, 12 electrons bond order is 2, then B2 10 electrons where will be there? 1, bond order is 1, then He 4 electrons bond order is 0, does not exist the molecule. He2 molecule do not exist. It's very important molecule even this is. So increasing order He2, then after B2, then after C2, then after N2. This is the order for the increasing. Clear my dear students? Clear? Understand all of you? Then one more question. This is the last question. Yes, look at all of you. This is the last question. How many of the following species have bond order 2? How many of species have the bond order 2? Bond order 2. This is the question. Look at the carefully. So A molecules, B 4 molecules, C 6 molecules, D 5 molecules. Then, sir, molecules are given actually. In the question itself, molecules are given C2, comma B2 2 minus, comma N2 2 plus, comma Cn plus, comma NO minus, then comma O2, comma C2 plus. Look at, observe it carefully. C2 plus. Sir, C2, how many electrons, sir? 12 electrons. B2, actually B2 10 electrons, then minus 2, 12 electrons again. 12 electrons, right? Then N2 plus 2, 14, 14 plus 22 electrons remove cheyali. Then 12 electrons. Then here Cn, carbon 6, nitrogen 7. So 7 plus and 12 electrons again. So NO, nitrogen, NO minus, nitrogen 7, oxygen 8. Nitrogen 7, oxygen 14, 15, 16. 16 electrons in this. Then 16 electrons in this. Then C2 plus, C2 plus carbon 12, carbon 12, then plus one of the electron you have to remove. Then 11 electrons. So here, wherever the 12 electrons are there, bond order is 2. Then 16 electrons are there, also bond order is 2. So only this molecule bond order is 1.5. So total number of molecules which are having bond order 2. Bond order 2 na molecules any 4 plus 2, 6. So this is answer. Clear? Understand all of you? Yes. So thank you. Then please follow my channel, subscribe my channel, like, and share it for every student who are preparing for JEE Mains and EAPCET examination in Telangana, Andhra Pradesh. Thank you. Thank you very much.